Cambridge exercise 2G, question 10. You get given this diagram here. We can see the angle of elevation here is 45 degrees in triangle ADC. We've got another right angle triangle here, ADB. The angle of elevation is 30 degrees there from B to A. And we have this ground level triangle there with a 30-degree angle there. That's all that you've got in that question. Now, the first part of the question says to find the length of BD and CD in terms of H. So we're going to go in triangle ABD. We can do the tan of B, the tan of 30 degrees, equals H over DB, or BD. So BD equals H over tan 30. And what's tan 30? 1 on root 3. So it's H divided by 1 on root 3, which is root 3H. Yeah? Then we have to come up with an expression for CD. So in triangle this time, for CD, you'll be in triangle ACD. We've got the tan of 45 degrees is H over DC. So DC equals H over tan of 45 degrees. So isn't that H divided by 1 on root 2, which is root 2H. Sorry? Oh, sorry, what's wrong with me? It's 1, which is H. Thank you, sorry. So H divided by 1, which is H. Okay, so now you've got expressions for your ground level diagram for BD, which is root 3H, and DC is H. So we're going to draw the ground level diagram separately, okay? So I'm going to draw that separately. I've got this, DCB. I've got 30 degrees. We know that DB is root 3H, and we know that CD is H. And I think they've called this one X, haven't they? I think they've called that X. So it says use the cosine rule to show this expression. 2h squared equals x squared minus root 3hx. So you'll use this. So we're going to use, we're not finding the angles, so you need to use the side version of the cosine rule. So we're going to do this one, like c squared equals a squared plus b squared minus 2a. So it'll be root 3h squared equals h squared plus x squared minus 2hx cos 30. That one, that rule. So this squared equals that squared plus that squared minus 2 times that times cos 30. Remember, cosine rule, 2 sides and the angle in between. Okay? So we've got root 3h squared, isn't that just 3h squared equals h squared plus x squared minus 2hx. What's the cos of 30? Times root 3 on 2. So here's our 2h squared. So 3h squared minus h squared is 2h squared equals h squared. Now the 2's cancel, don't they? Minus root 3hx. So we've got that. Now for part C. Was everyone okay with those bits? Let u equal h over x. Write your answer to part B as a quadratic equation in u. And show that h over x equals that. Now, at the moment, I can't see any h over x's, can you? How could you get h over x? You'd have to divide by x. You need to divide by x squared, actually. Because if I divide through by x squared, I'll get h squared over x squared, which is u squared. And that's going to give me my quadratic equation in u. I'll have x squared over x squared is 1, which is my constant. And h x over x squared is going to give me h over x, which is just an ordinary u. So that's how we're going to do this. So we're going to take this result, 2h squared equals x squared minus root 3hx, and we're going to divide through by x squared. Now, you'll see now what that's going to give you. So I've got 2h squared over x squared equals x squared over x squared minus root 3 hx over x squared. Now, if I simplify that, I've got 2 h over x squared. You okay with that? X squared on x squared is 1 minus root 3. The h stays, and I end up with 1x on the bottom. Now, that's looking really good because that's now u squared, and that's u. So now what I've got is 2u squared equals 1 minus root 3u. I'll put that in brackets. Now that's a quadratic equation in u. Okay? So let's take everything over to the left. 2u squared plus root 3u minus 1 equals 0. And what do you think you would do? Solve it using the quadratic formula. And it's saying show that h over x is this. H over x is u. They're just saying show that u is that. When you solve this quadratic equation, show us that you get that. Okay? Now remember, u is h over x. Normally with a quadratic equation, you get two answers. Why are we only getting one answer? Because h over x, the answer has to be positive. Because they're both side lengths. All right? So we don't want the negative answer. So let's see what we get. U equals negative b, which is negative root 3, plus or minus the square root of b squared is root 3 squared, which is 3, minus 4 times 2 times c, which is negative 1, over 2 times 2. So u equals negative root 3 plus or minus the square root of, this is 3 plus 8, which is square root of 11 over 4. So, if I do negative root 3 minus, so I've got two possible answers. So u, which happens to be h on x, is either negative root 3 plus root 11 over 4, or negative root 3 minus root 11 over 4. But this is not the solution. So u, which is h over x, could be that as well. Not the solution, as u has to be positive. Does this make sense? It's a side length. U is h over x. They're side lengths. As h is greater than 0 and x is greater than 0 because they are side lengths. So therefore that's your answer. So it's root 11 minus root 3 over 4. Because it's just writing the root 11 one first. I'll just put that down. Oh no, 2h. Question 15. A plane is flying at a constant height h. So remember, planes fly up in the sky. And the plane is at height h. Let's see where we start. A plane is flying at height h. So this is height h, so's that. That's the height. The plane is going either that way or this way. I'm not sure yet until we read the question. And it's flying with constant speed. And an observer at P, down here somewhere, someone standing here, sighted the plane due east. So this time, they've drawn, you're just going to have to take this for granted, that east is on that is actually east. I know it normally is drawn across, and actually sometimes we draw north sideways, but they've drawn it all on angles, all right? So that happens to be east. So an observer at P sighted the plane due east at an angle of elevation of 45 degrees. So remember, angle of elevation triangles. So this happens to be east, okay? And then soon afterwards, it was sighted again in a northeasterly direction at an angle of elevation of 60. So obviously the plane starts at A and then goes to B. The plane's going that way. Someone looked and saw the plane at an angle of elevation of 45 degrees due east. Remember, the due east is on the ground. The elevation triangle angle goes up in the air. Then a few minutes later, soon again it was sighted in a northeasterly direction. Now they're telling us that this is northeast. Now, just watch this. If that's north and that's east, and that is northeast, you tell me the angle between east and northeast. 45. So that's on the ground. So yes, the plane was later in a northeasterly direction, but the northeast is measured on the ground. So we go across northeast, but we look up and we see the plane there. The angle of elevation was 60 degrees. Now, for the ground level diagram, I'm going to use different colors. So the angle of elevation triangles are in black. All right? You got right angles there. My base triangle is in pink. My ground level triangle is in pink. Now, if this, I know it doesn't look like east and northeast, but if that is east and that is northeast, how big is this angle in between? That is 45. Now, that's a ground level diagram. I am going to draw another ground level diagram. Okay, now they've labeled these points C and D. My ground level diagram is D and C and P, and I definitely know that that's 45 degrees down there. That's what I've got on the ground. Now, I'm going to move this up. So this is what I've got. That's my ground. Angle of elevation triangles are easy. I'm going to draw them here. Here's one angle of elevation triangle, DBP, with 60 degrees. I'm going to draw the other angle of elevation triangle over here, and that's my ground. The other one is CPA. This is H. This is 45 degrees. That's a right angle. That's also H. So these are the three triangles we're looking at. Elevation triangles, ground triangle. All right. Normally, and I don't know what they're asking, normally we'll be finding these lengths on the ground. Let's just see if that is what we do. It may not be this time, because they might want to know how far the plane's travelled. But we can see how far the plane's travelled on the ground as well. You know, A to B is the same as C to D, the distance, because the plane's directly above. So I haven't looked at what the question asks yet, but they're going to either ask you a few of these things, all right? Typical what they're asking. Write down expressions for PC and PD in terms of H. PC is the ground distance here, and PD, great. They're very standard questions. So over here, what would we use in this triangle for PD? Tan of 60 degrees is H over PD, or DP. So PD equals H over tan 60. We know that tan 60 is root 3. I'm just going to make this bigger now. Root 3. Sorry. Now over here, again, tan of 45 degrees is H over PC. So PC equals H over tan 45, which is H over 1, which is H. So now we can put those lengths on our ground level diagram. PC is just H, and PD is H over root 3. And look what you've got. You've got the cosine rule on the ground diagram. Two sides and the included angle, and you can find CD using the cosine rule. Okay, so pretty much it's find lengths on the ground using your angle of elevation triangles. You'll always have some angle on the ground in this triangle. It's either going to be a northeast with a 90-degree angle. This one was east-northeast, which is a 45-degree angle there on the ground. Okay, so find lengths on the ground using your angle of elevation triangles. Then use the ground diagram to find any lengths and bearings, okay, on the ground. So let's go. So now in triangle PCD, we're going to use the cosine rule. So CD squared equals, do you know what to do? H squared plus H over root 3 squared minus 2 times H over root 3 times the cos of what? 45? Which is H squared plus H squared over, what's root 3 squared? 3. Minus 2, this is H squared over root 3. What's the cos of 45? 1 on root 2. Okay, now, what's H squared plus, we've got a common, we can add these two together. Isn't this 3H, I want to make, so what I want to do here, Actually, I want to make a common denominator because, yeah, I'm going to need to make a denominator of 3. Okay? Now, do you know what 2 over root 2 is? You know 2 is root 2 squared. I'll just show you over the side. 2 over root 2 is really root 2 squared on root 2. Are you okay with that? Isn't that what 2 is? Root 2 squared, which is just root 2. But you could have done it by rationalizing it. You can times by root 2 on root 2. You get 2 root 2 on 2, which is root 2. But it's easier to think of root of 2 being root 2 squared. You got double on the top than what you got on the bottom. Not double, but double the power. So 2 on root 2 can actually just be written as root 2. So I want to do that here. I want to go common denominator here too of 3. Can I write that as 3h squared over 3 plus h squared over 3? Are you okay with that? Do you know why I'm doing that? They've pulled out a 3, a third, as a common factor. All right? So minus, see this 2 on root 2? I'm going to write that as root 2 h squared on root 3. Are you okay with that? 2 over root 2 is just root 2. Now, I need this last term to have a denominator of 3. How do I do that? Times root 3 times root 3 will give me a denominator of 3. So this is now going to be 3h squared plus h squared minus, what's root 2 times root 3? Root 6h squared all over 3. Do you agree that it's all got a common denominator? Now, what's 3h squared plus h squared? Isn't it 4h squared minus root 6h squared over 3? And now my common factor is h squared over 3 is common, like it's a denominator. So, and I've got, so 4h, see this really is 4h squared over 3 minus root 6h squared on 3. That's really what it is. That's a 6, girls. So it's h squared on 3, 4 minus root 6, which is a third. H squared on 3 is a third times h squared. Okay? Which is 1/3 h squared, 4 minus root 6. Okay? That's an east-west line. So on what bearing does the plane fly? Look up here. It's this. I need, the plane's flying here, which means it's flying that direction. I need this angle. I know that this is east. All right, so let's just find this angle in the triangle, which is this one here. You okay with that? We're going to find that. And then we know that this line is east and this is northeast. All right? So we need to find that out. So I'm going to go to another page. All right? So this is what I've got. I've got 45 degrees. I do have some side lengths. I know that CD squared is a third h squared 4 minus root 6. I know that this length is h. This is h on root 3. I know that this is east, and I know that this is northeast. And I want to find this angle there. Sorry, you can't see what I'm doing. That's what I've got. Now, whoa, I'm wondering if we could use sine rule. But I've got, the plane is above here, flying above here, which means it's, remember the bearing's always done on the ground? The plane's flying above there, but that's directly above this line on the ground. Because the plane is h high. So yes, the plane's flying like that, but it's flying directly above this line here on the ground. So you just find the bearing on the ground. Remember, bearings are measured on the ground. So I need this angle. Now, I could use cosine rule. I don't think I can use sine rule because I've got h squared there and only h here. Because if I go sine theta over that equals sine 45 over that, I've got h squared. But I could. No, I can't. I've got a quadratic. The plane is flying along here. But you know that AB is directly above CD. The bearing is actually, the bearings from... I thought I'll just work out this angle in the triangle. We need an angle just because if the plane's flying along here, I still haven't worked out the bearing. I just want to work out an angle in the triangle first, and then we're going to work out the bearing. Now, I'm actually going to spin this around because this looks really weird as northeast and east. Do you know what I mean? What we've really got, I know we've got that there, but I'm going to draw it again. If this is north, this is east, this is northeast, right? That's really how it should look, shouldn't it? So this northeast line, isn't that right? If this is point P, is H on root 3. This P east line was H, and this distance, CD, was a third H squared 4 minus root 6. Now, if I want the bearing that the plane's flying on, isn't the plane going from the east, you know, from there to there? It's actually going like this. The plane's going like that. Ground level diagram nice and neatly. I know we have this there, but that is not showing it in the correct directions. That's northeast, that's east, that's a 45-degree angle. We know these measurements here, but I'm turning the whole thing around, all right? And I'm drawing proper north, proper east, proper northeast there. 45 degrees, I know that. This is H. This is H over root 3, or H root 3 on 3 is if it's rationalized. All right, so I can write it as H over root 3. So that's either H over root 3 or H root 3 on 3. Same thing. You okay with that? Because that's rationalized version of H on root 3. And that's that thing that we found there. I don't know why I've got... Oh, because that's CD squared, ladies. So that was CD squared from part 2. So this is the square root of that. And now we can use the sine rule. That's why I was wondering what was wrong. So now we can use the sine rule because wasn't part B an expression for CD squared? So CD is the square root of that. So now we can call this angle alpha or theta or whatever you want. And we've got sine theta over H on root 3 or H root 3 on 3. Do you want me to change it to H on root 3? It's the same thing. Equals sine 45 over that square root. Rearranging the equation, sine of alpha is sine 45 times H root 3 on 3 divided by the square root of that. Now, come on everyone. Let me just rewrite it. All right. Bring that CD is the square root of CD squared, so it's the square root there. So now we can use the sine rule. So sine of alpha over, I'm going to call this H on root 3, not the rationalized version of it, equals sine of 45 degrees over the square root of 1/3 H squared 4 minus root 6. Now, making sine alpha the subject, we've got sine alpha is sine 45, which is 1 on root 2, times H over root 3 divided by, you okay with that? Divided by this. Now, the square root of H squared, I can take the H out. Are you okay with that? And keep under the square root sign 1/3 bracket 4 minus root 6. Now, this is really good because the H's will just cancel. There's a H over root 6 on the numerator, so this is what I've got. Sine of alpha really is, let's look at the numerator, isn't it H over root 6? And then we're dividing it by this thing. You okay with that? Which really means times 1 over that. Are you okay with that? If I'm doing that divided by this, it's that times 1 over this. Now, when you've got fraction over that bottom bit of the fraction, that root 6 ends up sitting down here next to that, you'll find. Because it's H over root 6 divided by this, which is times 1 over the denominator. Now, look at the H's, they cancel. Thank goodness. And now we've got 1 over root 6 times root 1/3 4 minus root 6. So can't we, when you're when you're multiplying, you know the square root of A times the square root of B, you can put them all under the 1 square root sign. That's a rule. So that's 1 over the square root of all of it together, 6 times a third, 4 minus root 6, and it just helps you work it out. Now what's 6 times a third? It's 2. It's 1 over 2, 4 minus root 6. So that's what sine alpha is. Now that's something that you can, so its sine alpha is 1 over 6 minus, no, 1 over 8. Sorry? No. Sorry? This is the square root of all of that, 1 over the square root of that. So now you can just do that on your calculator and get a value for alpha. So you should get, alpha is, I believe, 34 degrees, 36 minutes, which is approximately 35 degrees. Now we have to do the bearing. Now I'm going to go back to that diagram. And so the bearing, if we look at this diagram here, so this was north, remember that's north, that was east, that was the northeast. We had the lengths on our triangle. You put it, if you want the bearing, the plane is flying from C to D, okay? So the bearing, put a north sign and go clockwise until you find the line that you're looking for. That's 90, 180, it's 270 plus whatever alpha is. Can you see that? So the bearing is 270 plus 35, which is 305 degrees. So a bit of a hard one, that one.